Before we do this practice question, I just want to say that this derivative example is taken from my Civil FE full in-depth review course. So in the course, this is going to be under the mathematics section and under the section of single variable calculus, where we discuss derivatives, learn how to take derivative of functions. We will talk about the concept of derivatives. What does a derivative really mean, just in case we get a conceptual question. And we will also apply the calculator, both the TI-36 and the Casio, on how to take derivatives for specific problem statements where the calculator is the most speedy and time efficient way to actually solve the question. So if you're looking for a full in-depth review course with step-by-step solutions, video solutions, and plenty of lesson notes where you have unlimited support and a course that is likely to keep you engaged, check out the course in the description. And if you have questions at all about the course, please let me know. Okay, so now we got ourselves a straightforward example where we want to take the derivative of a function as it's given. So we're told here the derivative of the function is what? So what is the derivative of this function? So we know here, let me first begin by writing this again so we can see and simplify it. We know it's going to be open parentheses 3x minus 1 divided by x squared plus 3, and all of that is raised to the second power. So that power is important, right? This whole thing is raised to the second power. So now when you see this, you should automatically, if you've been practicing or looking into derivatives, it's something like similar to a function that encompasses another function. Or we have an inside function. So we have this inside function that's inside a bigger function. So we have a function that encompasses another function, and that's when we use the chain rule, right? So when you, for example, have like x plus 2 raised to the fourth power, you use the chain rule, right? You have this function that's inside a bigger function. A function encompassing another function is a hint that we use the chain rule. But we know in this case, it's a special case of the chain rule. And we call that the general power rule. And in fact, it's going to be rule number 8 under the derivatives in the FE Handbook. So I want you to keep up with me here. What you can do now is go to your FE Handbook. I have mine pulled up under the PDF, using that PDF. Go under derivatives and find that rule number 8. We're going to apply that rule. And rule number 8, we call it, textbooks usually denote it as the general power rule or a special case of the chain rule. And for the FE, I want you to think of it as just the chain rule. And we'll use that rule and we'll see how that's actually what's happening here, right? We have this function and we have a function inside another function. Special case of the chain rule, general power rule. So anyway, we will say that's going to be rule number 8, and that's what we're going to apply. Rule number 8. And we call that the general power rule. General power rule. Or you can say it's a special chain rule. Chain rule. And we know that special chain rule is when we're dealing with specifically polynomials, right? We know we denote it as special chain rule. But anyway, that's the rule we're going to apply at the beginning. So let me write that for us. Rule number 8, as it's given, it's going to be du raised to the power of n, and then it says divided by dx, so the derivative with respect to x is going to equal to the n value. We take u's always a function, n minus 1, then we do du dx. We take the derivative of the function u with respect to x. That's what this is saying. So now, we know this is what we have, right? We have that because if you look closely, this u is this, right? It's that function. So this whole thing, you can think of it as the u, and n is going to be the power. So this 2 is n, right? The n value is going to be that 2. And that's why we will use this rule number 8. So now it says when you have this case, you just apply this. So that's what this is saying. The derivative, when you have this case, equals to this. So we're just going to use the right side, right? The right side of the equal sign. So now using the right side of the equal sign, the n value is going to be the power. So that's going to be 2. So we put in 2 for that. So the u value is the function, which is this whole thing, right? It's the entire thing in that parenthesis. So we know it's going to be 3x minus 1 divided by x squared plus 3. And then you do the n value minus 1. So what's the n value? It's still 2, right? 2 minus 1. Okay, so now this it might be a point where you stop, right? When you're using these rules. But be careful. We still have to do this. So we have to do the derivative of u with respect to x, right? Of the function u. So when this is next to, so this is next to this, that's saying, okay, multiply them, right? We have to multiply. So let me put that dot for multiplication, and it says the derivative of u with respect to x. But what I'm going to do is just denote it like this, so we can see what's happening. So I'll keep that d, and u is the function. Again, u is going to be that whole thing. So we will take the derivative of that. So let me write it here, of 3x minus 1 divided by x squared plus 3. And I'll write it on the outside here so we can see it, but we take that with respect to x, right? dx. Again, this is going to be our u, right? This is our u. And this is what I did. I plugged in the u, and we're doing the derivative of this with respect to x. So now this is when it gets tricky and it gets complicated for an FE type question. But we're trying to practice and trying to get some of these difficult questions in case we get them, and to be over prepared for something like the FE. But here, we know here, this cannot be easily simplified. We actually have to apply another rule, and we'll do that, and that's going to be the quotient rule. So we'll get to that, but before that, let me just simplify this. So let's quickly simplify what we have here. So we have the 2, and you do 3x minus 1. Just reducing this so it looks better, plus 3. And all of that, 2 minus 1 is just going to be 1, right? So what you have there is 1, and usually we do not write 1s, right? So you just write it as that, so you don't show that 1. So that's what we have here, right? We reduce that. But now we do the multiplication. What do we put here? What do we put here? It's going to be the derivative of this function, of that function u. So this is saying take the derivative of u. And we know in that case what's happening. We have a function divided by another function. This function divided by this function tells me we have to use the quotient rule. When you have division, let's use that quotient rule. So now the quotient rule is going to be rule number 7. Rule number 7 under derivatives in the FE Handbook. And let me denote that here. This, we have to use the quotient rule. Quotient rule. Quotient rule. And let me denote that down here as well. So it's going to be rule number 7. And we call that the quotient rule. So that's what we will do for this. Then we'll just plug it in there and keep going and reduce it at the very end. So now we're going to apply the quotient rule. The quotient rule is written as follows. So let me denote that. So it's going to be d u over v divided by dx. Just rewriting this, and we take the v value. We do the derivative of the function u with respect to x. Then minus the u, the function u. And we take the derivative of the function v with respect to x. And all of that is divided by the function v squared. So now you have to denote what's v and what's u. So be careful with this. We said the entire thing at this point is u. But now we have to go back and denote the u and v by themselves. So what we're going to say is u is going to be the top one. So I'll use this color. This is going to be u. So it's u divided by v. And v is going to be the bottom one. So v is going to be that. That's our v. So those are the functions. U is the top one, v is the bottom one. So now that's what we'll do. So simplifying this, applying the quotient rule, the v value is, all you do is put that v value, right? It's x squared plus 3. So let's just put that. x squared plus 3. And I like to make it a habit of keeping those parentheses there, especially when you're using the quotient rule. So I'll do that here. Then this is saying take the derivative of the function u with respect to x. So doing that, the function u is going to be this, right? And we just take the derivative. So a lot of us might probably know this right off the bat. So the derivative of 3x should be just 3. You just use the power rule, the simple power rule. So that should be just 3, right? And the derivative of a constant is 0. So neglect it. Just ignore it. Don't include it. So here, the derivative of this whole thing, which is like the derivative of function u with respect to x, is just 3, right? When we take the derivative of that. So that's what we put for this. We multiply by 3. Then you do the subtraction. Do that. Keep it. Then you do the u. U is going to be that one. So it's going to be x squared plus 3. Then you do the derivative of v with respect to x, the function v. So now we're looking at this. The derivative of 3, ignore it. It's a constant. It's 0. Don't include it. The derivative of x squared is going to be 2x, right? You move the 2 in front, then you do 2 minus 1, and you get 2x. So the derivative of this whole thing is just 2x. So that's what we put for this, 2x. So now we're done with that. We're almost done for that quotient part. So you do v squared at the bottom, and v, again, is going to be this one. So it's going to be x squared plus 3 squared. X squared plus 3 squared. So that's what we have for that one. And then we keep going. Now we can actually simplify this further. We can distribute these. So distribute that. And what we get for that part is going to be 3x squared plus 9. And I'll keep it in parentheses at this point. Let me do the subtraction symbol. So let's distribute this, distribute that. And you get 6x squared minus 2x. And then all of that is divided by what we have on the bottom. So let's just keep that. Keep going. Squared. So now we're almost done simplifying just this portion. So now we do equals to. Now what you can do is combine like terms. So like terms is the x squared is going to get combined with this. But be careful here. That's why I like to make it a habit of keeping that negative at the very end, or the minus. This negative makes this negative, right? So it's going to be 3x squared minus 6x squared when you combine like terms, the x squared terms. So for that one, you should get negative 3x squared. Then you do the plus 2x squared, and that's going to be plus 2x squared, once again, because this negative and negative becomes a positive, right? This negative hits this one, it's being multiplied. Negative times a negative is a positive. So this becomes positive 2x squared. Positive 2x, right? Positive 2x. Then you do plus 9. You keep that last one. Then all of that is divided by what we have at the bottom, which is x squared plus 3 squared. So now we are basically done just applying the quotient rule, right? So this is what we're going to put in here, right? That's what we will put in here, because that's what we did. We applied the quotient rule, which was rule number 7, to simplify this. And that's what was done. So that's what we have. We're going to take that and put it in there. So doing that, just to show us everything, it's going to be negative 3x squared plus 2x plus 9. And all of that is divided by x squared plus 3 squared. And that's what we have there. So this is basically completing everything. We did the derivative. So you can probably pick an answer just based on what we have here, if you look at the answer choices closely. So obviously A is out, right? A we can eliminate. We know that at the bottom, if you look very closely, this x squared plus 3 is the same as this, right? And this x squared plus 3, we can think of it as having a 1 power. So when you take this times this, you should get x squared plus 3 to the 3rd power. X squared plus 3 to the 3rd power. Because you're taking this times this, you just add the power. 1 plus 2, it's going to give you a 3rd power. And this just stays the same, right? That just stays the same. And on top, you have 2 times 3x plus 1 minus 3x squared plus 2x plus 9. So I believe the answer for that one should be B, right? It makes sense why it's B. And the most important part, just note this times this gives you x squared plus 3 to the third power when you multiply the denominator values. So the answer should be B for that one. I know this is relatively a long one for a derivative, but if you know how to do this, I believe you should tackle a lot of these derivatives. That's all. If you have questions, let me know, please. Thank you.